Hi, everyone. I'm Patrick McFadden. I do a lot of things at DataStax. Primarily, I work on open source projects. I've been working with the Apache Cassandra project for quite a few years, more years, probably about 10 years. I'll just say it, 10 years, since it was an early project. Lately, I've been working a lot with Kubernetes and a project called Cassandra, which I'll talk about pretty soon. Um, just spending a lot of my career, my background and career is in running an open source infrastructure. I've been doing internet infrastructure for a long time, and open source has always been a part of it and has been a really strong part of my career. So I feel pretty passionate about this topic. I've given talks before on the business of open source, how open source licensing works. I was a mainstay at OzCon. If any of you had ever gone there, pour one out for poor old OzCon. I'm sad to say there will never be another one. But we have great open source conferences like Open Source 101 and All Things Open. I think we're going to keep going. But let's just get into this. So my talk today is going to be a bit of a story. Hopefully you'll enjoy it, but there's a moral to the story. So those Star Wars fans out there, a long time ago in a data center far, far away. And I think this is when the music starts, right? Well, here's the sad music. It's kind of grim times right now. And when I say grim times, there's just a lot of bad press going around about, the demise of open source. And I'm sure you've seen this. This is the whole idea that the clouds are strip mining. And this is, I put it in air quotes, but it's actually in quotes on my presentation, strip mining the open source projects. And what that means, what strip mining means, is that they're taking all the good stuff and wrecking the ecosystem. Or, I think that's where that came from, is that it just takes all the resources and leaves this horrible barren landscape. And what it really comes down to is, that there's a lot of open source projects out there that have made an enormous mark on our open source infrastructure, or infrastructure in general. And there's feeling like the MariaDB CEO saying, basically, this is ruining open source because they're taking and they're not giving back. And there's no one contributing to MariaDB, which was in this article. And even to the point where, like, Elastic has very famously been going after Amazon with changing their license terms and even considering suing them. It's getting pretty serious, right? And then Amazon has been trying to wave this flag. It's like, no, we're just as open source as you are. We're just different. And so this is a war going on, a very cold war for sure, but it's happening. And there's a lot of folks that are saying this could be the end of open source, because what are you going to do when you're just renting everything from a cloud? And I love this scene because when you look at this, you're like, yeah, that doesn't look so good. But there is a prophecy. And I'm not here to say that this is actually a prophecy. What I'm saying here is that we're going to use history as a bit of a teacher, and I'm going to make you feel a little bit better. It's not going to look so bad when I'm done with this. So going back in history, there's always been this problem, or this just trend, where relative cost of IT infrastructure always increases with scale. It's fairly linear. And of course, with all of the, the infrastructure that we have to use to scale up, it's going to come with a cost. And it's repeated itself quite often throughout history. Technology just in general, whenever we have a little bit of it and it costs a lot, using a lot more starts reducing the cost, but there still is a linear relationship over time. And we've seen this many times where eventually there'll get to be an inflection or a cut point. Like, the cost and the scale meet at a certain point where people aren't happy. And when that happens, when that moment occurs, we have to really stop and think, okay, how are we going to move forward? Because keeping going up and to the right continuously is just not viable right now. And so that's when we find ourselves in, as smart engineers as we are, we come up with alternatives or we change the equation. Now, this has happened over and over again. So way back in a long time ago, mainframes were the IT infrastructure at the time, but it cost millions and millions of dollars if you just wanted to do a little bit. And it just got out of control scale. And of course, if you were a huge bank or an insurance company, sure, that made sense, or a government agency. But the scale was not portable and it did not work for what needed to happen, like in smaller businesses, for instance. And so client server computing came along. That was when we had companies rose up like Oracle. That was when those started. And then eventually we got to the point where client server, because like companies like Sun, if you want to use their computer, it's big and it's heavy and it's really expensive. Internet changed a lot of that scale as well. So now we have commodity computing and virtual machines and things like LAMP stack that really cheap, like reset all the costs again. And so you get this sawtooth pattern over and over again. And then, but we were still installing our own infrastructure at the time. And so when we were doing all this great stuff, like, like building out these big, massive websites, we were building our own data centers as well. But eventually what happened is that we got into this cloud thing, and that's, that reset it things again. We're no longer building data centers. And so now we're in that mode. This is where we are. And that's why it's kind of fading right now. So where are we today? Whoop. And those heroes in that world centered around like these projects that were starting to band together in these tribes, and like the Apache Software Foundation, the Linux Foundation. I mean, think about this, is like for the last 30 years, at least 20 years in real, I mean, the Linux Foundation and Apache Software Foundation have been around a little over 20 years. But in the past 30 years, these are projects and foundations that have made a remarkable difference in how open source economics has affected IT infrastructure and the relative costs. So when we talk about open source, we're talking about the two things that are pretty common that everyone talks about. There's a free as in freedom and free as in beer. And who doesn't like free beer, right? That's me on the right, by the way, the very, very far right. I was doing a conference in Munich and found out that even though the beer isn't free there, it sure is awesome. I can't wait to get past COVID so I can start traveling again, because I want to go back. But this free as in freedom, free as in beer, two very distinctly different freedoms, right? But big impact on how we reset our economics. Because free as in freedom means deploy wherever you want. There's no license restrictions that say, oh, well, you can only deploy it on this type of machine. Like I used to work with a lot of Sun gear, and you didn't install SunOS on your commodity server. No, you had to have a Sun hardware that was exactly specified for that piece of software. And so the license was not available for me to run it on, say, an x86 machine. Eventually we had Solaris x86, but not during the 90s. And so when Linux comes along, I can deploy it anywhere I want. And as long as it runs x86 code, it works great. And then the license cost. And I think this is where most folks are like, yeah, I mean, that's great, but is that really why you're here? Yeah, it's a big reason. Come on. I mean, when you download a piece of software, a world-class piece of software, like I said, I work with Apache Cassandra. This is probably the most powerful database in the world. It runs everything that you can think of, from your cell phone to your entertainment to your banking. And the cost to you is 100% zero. Now, you can go with a company like DataStax, and we help you do a lot of with Cassandra, but the core part of that is free. And if you want to download it from apache.org, it's up to you. And you can run it anywhere you want. And that kind of freedom has enabled a lot of really interesting things. Let me give you an example. Facebook in 2008. And this is actually when I was working in infrastructure. I didn't work at Facebook, but I was working at other companies in Silicon Valley. And this was a crazy time for everybody in open source because where we were and what we were doing was totally fueled by open source. So Facebook in 2008 had 1,800 MySQL servers. And that was a lot in 2008. I'm sure there are companies that had similar numbers. Google has a lot of infrastructure at the time. Facebook was a hyperscaler. And then I think MySpace was also one of those. Yeah, well, not anymore. But YouTube was just starting to become a thing. And Twitter, but when you talk about 1,800 MySQL servers, what are those running on? Well, those are running on 8 core servers. And 8 core servers means that now if I was to go to Oracle and say, I would like to buy a license for, say, instead of MySQL, I'm going to run Oracle. And you could even license MySQL if you wanted to, but let's say we're just going to buy an Oracle server to run all of Facebook. Well, the list price in 2008 was $50,000 per core. And so 8 cores each, do the math, that's $720 million. And I think at the time, Facebook had taken probably maybe $120 million in funding. I think it was 150. And it was just a lot of money. This is like, strange, crazy example, but it is what fueled Facebook is not having that overhead of cost. They bought some really great engineers, they rented them, and they spent their money on people, but their people were moving the technology forward. Now, okay, let's say that you got an 80% discount. That's still $144 million worth of Oracle licenses. Facebook would not have done what they did. And by the way, this is a snapshot in 2008. I remember seeing, like in 2009, this number almost doubled because this is when they were in hyper growth mode. And could you imagine like a weekly call to your Oracle rep? I need to buy another 5,000 licenses, boy, that rep would be really excited. But, this is an example of when open source was just the fuel, because the meetings that they were having were advancing technology. And what happened as a result of that is that Facebook actually started not just using MySQL, but started contributing to it greatly, but also building some really cool Apache projects like Cassandra. Cassandra came from Facebook around that time. And they did a lot of work on HBase and on Hadoop and Presto. I mean, they have a lot of contributions. Now they're doing React. So open source has benefited greatly from that because they're just taking it to a whole new scale. So let's go back to today and where we are. Well, we are now doing this. So I replaced my just generic hand wavy, here's cloud infrastructure. And let me replace this with this, which is cloud dollars and cloud usage. And it's going up and to the right now. And we don't really know where this is going to go, where it's getting too expensive. But I will tell you this, it is getting expensive. And just go out and look at how many startups are out there that do nothing but tell you how to spend less on a cloud. So in that case, I'd say we're getting there. I don't know what it's going to take. But what do clouds really sell? They sell you 3 basic things. Every cloud sells you these 3 things, which is compute, network, and storage. That's it. Now, I know what you're going to say. No, they sell me a lot more than that. But no. This is fundamentally what they sell. And the reason that they sell that is because they build these. This is a picture of Amazon East, I think probably one of the AZs. It's nice, thanks Google Earth. And get a nice snapshot at the top of the roof. But these data centers, and I used to work in Northern Virginia at data centers like this. And if you go through like places like Ashburn, there's a lot of big buildings with no windows and really small parking lots. And they don't expect a lot of people to live there, and huge loading docks. And why? because they're data centers. And these are really expensive to build. They're somewhat expensive to maintain. They require a lot of a specialty power, like redundancy. They have cooling requirements. You see all those units on the top there. Those are all cooling units. These are built specifically for scale compute in a single place. Now, if you're a company that's trying to make your mark in the world, starting out by building one of these will take you years. And so eventually we started renting the space inside of these. Now we're just renting the instances on top of it, the compute, network, and storage. And so thankfully, companies like Amazon and Google and Microsoft and IBM and Oracle have all spent their hard built capital over the years into building out this massive amount of infrastructure. And I'm really thankful for that, because what I get out of that is I get all the hard parts of running infrastructure, which is having, things like worrying about things like redundant power supplies and having good, clean networking in and out and making sure that that's redundant and we don't have any downtime. So when we build these, when we use these, we're taking advantage of that. But what these cloud companies have done is they're like, well, we want you to use ours. Let's make this sticky. So they started offering these things as platform as a service. And that means that they do a web server or dev tools or middleware or databases. And these are all the services that they sell you. So, and they're very popular. Like Amazon has some very popular databases. They sell a variety of middleware tools. And they even have tools that'll help you just do like continuous integration, continuous build stuff directly in Amazon. It makes it really super simple. And I mean, they're doing this on purpose, and you're kind of going for it, because what you're doing is you're saying, yeah, I don't want to do anything else but Amazon. And they get that, because what eventually they're going to sell you, and what they're ultimately selling you, is compute, network, and storage. These are just gadgets and sticky things to put on top of it so that you don't leave, because they have to, the only way that they grow is when they put more hours, instance hours in, and more traffic over the network and more bytes being stored in their storage arrays, because that's what they get paid on all the time. So if you look at the costs that are associated with those services, they're just an additive cost. And what's interesting is that that's where we get the most flexibility. Is you'll notice that there are clear loss leaders in a lot of clouds. Loss leaders being, hey, we took this service and it's a lot cheaper than any other service on any other cloud. Well, because they want you to move over to the cloud. Azure, for instance, with Cosmos DB, they really, really want you in there. And so they will take a lower price on Cosmos DB to get you in there so that you'll start putting all your other stuff in there, your web servers, your dev tools, your middleware. And data is super sticky, and they know it. And why? Because we're building, everything that we build always needs one thing, and that is a database. Whether it's you're building web and mobile applications, you're building microservices, you're doing IoT work, you name it, it probably will have a persistent data store somewhere. And if the only exceptions are if you're just storing raw data, say in something like an object storage like S3. But by and large, every application has data. And here's the other thing about data. Data is really hard to work with once it's firmly set up. You can't just pick it up and move it around. And yeah, they know that, because this is what they do. They say, hey, let's build a walled garden where your data lives, and you're stuck. You are now in the fortress of open source to stop open source. And they do a really good job of making sure that it looks great. But what they don't like to talk about is how completely unportable it is. Example, there are very similar services to open source databases running in clouds. However, they will not replicate and they will not migrate to other versions of that same open source database outside of the cloud. And that's on purpose. And you can't blame them. They're trying to get their money, and this is how they grow. But this walled garden of, hey, you're inside here and you're doing things with data, they could just like start counting their money at that point because you're in there for years. And if you ever get angry at them and you don't like the cost, well, then, okay, sorry, go ahead and move your data if you think you can, and you can't. Have you ever noticed that the most expensive thing on clouds is egress costs, data leaving the cloud? They don't want the data to leave the cloud. They want it to be in the cloud. And they've proven it with their pricing models, all of them. So all is not lost. Our cause is not over. We have a new hero. And this is the exciting part of this talk. Just hang on, here we go. Kubernetes. Now, I know Kubernetes is not new. It's been around for a while, but it's really picking up steam now. And why is this a hero for the open source thing? Like, we're trying to make open source survive and thrive. We do not want it to be the end of open source. Well, at this point, Kubernetes has started rocking the boat. And how is it rocking the boat? Well, not just the fact that it's really, really popular. I mean, it has completely swamped everything at this point. But you'll notice that this is the one thing that allows you to do something that is pretty hard to beat when it comes to cloud. So let's just review. What does Kubernetes do? Well, it takes a group of containers, applies a little magic, and that magic is what we also call orchestration. But it takes those containers, rounds them up, compiles, puts them together, and deploys them into a virtual data center. So long time ago, I would build physical data centers. And then I would use the data center provided by the cloud and I could deploy virtual machines like instances or containers. Great. But now we're at the point where we are deploying entire virtual data centers. And that's pretty cool because an entire virtual data center like that now gives me a lot of options. And those options are in where I want to run it. If everything is super portable, then I don't have to go down the route of getting myself locked in or worrying about like, well, what if I have to move? I'll give you an example. And this happened a few times. A few years ago, Target, company here in the US, which is a retailer, their CEO made the announcement that they will be leaving Amazon Web Services. And why? Because Amazon Web Services Amazon was a competitor to Target. And their CEO just hated giving money to Amazon when they were a competitor. So they had a very public announcement how they were going to move everything over to Google. Now, they are a huge user of Cassandra. And so that part of the deal was not hard because Cassandra can run in any infrastructure. But it also required them at the time, because they weren't using this particular technology, it required them to make some pretty manual moves. But it was great for them to move out and have that portability. Imagine if it was just a deployment YAML and you could just take a virtual data center and lift and shift it over to anything you want. And that's super scary for clouds, really scary, because you're turning a virtual data center into a machine that you have inputs and then you have outputs. And the underlying compute, network, and storage is really the only thing you're buying from them. So you're turning them into a power plug. So this is an example of a North American power plug. And there's a real beauty in this. And the reason I use this as an example is a long time ago, if you were running any kind of industrial application or doing like in a city, power was just locally generated. Electricity was locally generated. There was no standard. So could you imagine if you had to buy, say, your blender or your washing machine or something like that from your power company because it was the only adapter that worked? Like, you couldn't just buy a washing machine and have a standard plug. And that would be like today with cloud. Well, when we're talking about creating virtual data centers on top of compute, network, and storage, it turns it into a power plug. And we're getting commodity level, we're reducing the clouds down to what they really are and turning them into commodity players. And when that kind of competition heats up, the only winners are going to be us, because we're going to be able to take advantage of that competitive pressure. And here's the domino that I would see fall, is when we see egress prices dropping. Oracle's already done it. Oracle has said, nope, egress prices are the same as ingress. And so, because, when you're way behind on the cloud, you got to do anything to get ahead. But I think this is a moment. We all have to take advantage of this moment. What are we going to do with this moment? Because here's the target, right? We found their weak spot is that they have this really cool, great infrastructure, but we have Kubernetes that will make it abstract. And we have a plan. So Lord Helmet's sitting in his TIE fighter, a little nervous right now. So where are our heroes going to go from here? Well, Kubernetes. We got a plan, but here are a few things about Kubernetes that we're going to have to do. We're going to have to work on together. So Kubernetes is really awesome at stateless services. That's like the load balancers with network, things like microservices, which are usually stateless, middleware that just passes messages around, that sort of thing. But the middleware processing like Akka, that sort of thing. If you have been using it for that, and classic is like just web serving on top of Kubernetes and doing scale web serving with Kubernetes, that's been rocking. It's been really good. But what hasn't been really as well done, or hasn't been thought through as much, is stateful services. And stateful services can be somewhat hard for a lot of reasons, but these are where you do things like file serving your database and like more persistent messaging like Pulsar or Kafka. And it's because there's just a whole different class of service. Stateless is great for distributed computing because if you lose one, you just replace it. There's no setup, and it's fairly cheap to move parts in and out. Kubernetes as a technology is really, really good at making sure that if something dies out, it'll come back. And so we have this band of rebels working together now. I'm going to do a shameless plug for this community that I've been involved in called DOK, Data on Kubernetes. And this is a group of people from various companies, open source projects, et cetera. And I really invite you to join us here, because this is where a lot of really cool stuff is happening. DOK community is an independent organization right now. But this is a group of people that are looking at data as the thing to solve. We have a plan. Because the cloud powers we love, like these are things that we really love about the cloud, is you get this on-demand scaling, yay, because things happen and you don't know how much you need until you need it. And then when you need it, if you get it, you're happy. And that elastic pay for what you need. And elastic is so good because back when I ran infrastructure, if you bought too much of too many servers and you didn't need them, well, you're still paying for them. And even a lot of things that we use today still don't scale down very well. But if it's elastic, pay for what you need, you can save costs. And then there's that uptime. Remember back that picture I had of the data center? Yeah, they're really, really good at building data centers. And that near 100% uptime is going to be like a fundamentally down to the like electricity and cooling and all the things that happen network. Getting that near 100% uptime in the cloud is really important. Now it's not 100%, but it's pretty close. And they do a really good job of keeping their stuff online. But these are the cloud powers that we love. But can we bring those into a system? Because that challenge of stateful services, that storage, network, and placement these are the three things that we're challenged by. So storage is like, for instance, if you have any questions, thank you, Ruth. Yeah, if you have any questions, put them in the Q&A. I haven't seen any yet, but Ruth, let me know in the chat if there are any.
Sure.
So these challenges that we're having to deal with in cloud storage are, or in cloud, or sorry, in Kubernetes to get our cloud magical powers. Storage. Storage is a big one, probably the biggest, because there's just a class of storage that has to be there for stateful services. We need to think about how well it performs, that type of capacity, elastic capacity especially, and then really backup, doing snapshots, that sort of thing. The kind of storage that was in place for stateless services was very ephemeral, just came and went, and now we can't really do that with data. So that's a big subject inside the data on Kubernetes world. And then also network. And there's just some different classes of networking. Actually, the one that I'm most interested in is transit, moving data from one Kubernetes cluster to another, say if maybe it's across country, across the world. This is a thing that's being solved right now. It's a big challenge in stateful services because a lot of that relies on replication. And then finally, placement. I'll use an example of Apache Cassandra. Cassandra has its own idea of where data and nodes are arranged inside of a physical infrastructure. Kubernetes has its own ideas. And so whenever you think about, like, when you're putting together a large group of servers that act as a cluster, distribution, like where those things are and how they stay online. For instance, if you Kubernetes with a pod, you have a bunch of different servers that are running in containers that are running on a particular server. If that one went down, then you take your entire cluster with it. Well, that's a bad idea. Let's not do that. So there's things to think about in that regard. With stateless services, it's pretty easy because you can just throw them anywhere and everywhere and they're fine. And then finally, the coordination. If a node goes offline in a distributed system, a database like Cassandra, you have to think carefully about how you bring it back online. You don't just replace it immediately. There's some consideration about like where the data is and again, where placement is. So these are things that we're working on right now. So we have a new champion now. And this is part of what I wanted to talk about today. And I in the subtext, I say it's actually an old one with a great makeover. I've been talking about Apache Cassandra here and there. Well, the project that I'm also working on is K8Sandra. And K8Sandra is it's a project to collect SRE knowledge around running a scale database like Cassandra in Kubernetes. Because Kubernetes started before Kubernetes, Cassandra started before Kubernetes was a thing. And it was doing distributed way back in the day. And now that Kubernetes has become the dominant way of distributing destroying your infrastructure. It could do that too if you're not careful. Your dominant way of distributing large scale infrastructure, especially around applications. Cassandra has always been looked at in that, but now there's just a large group of infrastructure people that are like, well, I want to run Cassandra and Kubernetes. I don't want to have two different control planes. I want to have one. So K8Sandra is a project to do that. And it's a pretty interesting project because what it is, and it's changing the way some of the dynamics in open source. Cassandra is an Apache project, an open source project. But we're adding in things like Stargate, which is another open source project, which provides a data gateway on top of Cassandra and other databases soon. It uses all the Kubernetes ingress for external access. It uses other projects called Reaper and Medusa, which are part of the Apache ecosystem, for doing repairs and backups on the database, like your daily maintenance tasks. And then it takes advantage of all the observability tools like Prometheus and Grafana to make sure that your databases are monitored and things are going right. You can see it. And this package of things. So what we're doing now with K8Sandra is we're building a service tier for data with everything that's needed in Kubernetes. And it's a project of projects. And what I like to describe this is that because we're using things like Helm charts, this is a lot more than just a bunch of bits. This is where SREs that are deploying scaled data services on Kubernetes can compile all that information and knowledge and share it with each other. Because that is one of my favorite features of open source is when we're sharing information, putting all these things out in the public and making everyone better. And there are some really interesting large Cassandra installations out there that are moving into Kubernetes. And if you're just starting with data on Kubernetes, you're going to be able to take advantage of this years of experience running scale data services on Kubernetes. And that's what it's about. And what we want to build here is, and this is just one project doing it, but it's also, I think it's a great example of how we can take back a lot of what we need in the clouds, which is it creates this package of things that normally we would rent from a cloud. Now, I have to tell you that Cassandra, was started at DataStax, but it's really an open source version of our own cloud database called Astra. Astra is a Cassandra as a service that we run, but we run all that on Kubernetes and we run it on any cloud. So here we are. Cassandra is that open source version of that because we have our own SRE knowledge and we're working with other companies to get Cassandra in a place where anyone can just do the most scaled database ever. You could run a Netflix scale database on what kind of budget would that be? Hulu? No, Hulu uses Cassandra too. You could do your own thing. So here's like the really cool thing about what we can build now is we can go from, say, a laptop using Minikube, which is a lot of fun. I love Minikube. Minikube lets you run a Kubernetes cluster on your laptop. Be careful, you can burn up your laptop. But you can take a deployment YAML, which has all of the bits, everything you need to run a scale application. The ingress, the load balancing, all the different containers for the microservices, your service mesh to glue it all together, the storage profiles, the database services that you're going to run. Take all of that, one YAML, deploy it, or I'm sorry, commit it into Git so that now this is just everyone's configuration for our application. So a developer could go to their laptop and deploy it using Minikube, and they get a virtual data center right there in their laptop. Yay, team. But what if I wanted to take that? Hey, I'm still using a lot of on-prem data. Well, like VMware Tanzu, which is a Kubernetes for on-prem. You can take that same YAML file and deploy it right into a virtual data center. What if you're in a cloud and you want to do this? Well, same story. Azure Kubernetes Service, AKS. Just take that YAML file, deploy it, that virtual data center in Azure. Use their big three, their compute, network, and storage. And you're starting to commoditize the clouds. And if Azure doesn't really, let's say that their compute, network, and storage prices are a little out of bounds, and you're like, I think it's time to get out of here and go to a cheaper alternative. Sure, you could do that. You can run it in 2 clouds if you wanted to. And this is kind of a thing now. It's where we've gotten over time because, through acquisitions or you just want to try a different cloud and before you know it, you're in 2 clouds. Great. I mean, being more than one cloud is pretty common now. And it's not something you did on purpose probably, but you're there. It's going to happen. But what I think is really cool is that now you are using the compute, network, and storage for all of these clouds if you're using Kubernetes. And when you're using Google Kubernetes Engine or Amazon EKS to deploy your infrastructure, you're getting the best price that they can give you on those things. And when they don't give you the best price, then you can just move your virtual data center to something else. And Kubernetes is gonna create this situation. We just have to get it right with the data, and I think we're gonna be okay. But this is a really cool future that we're building right now. And it will create a lot of competitive pressure in the clouds, and who knows what will happen then. So these are the 2 futures that I think we have. We have this future where we could be living in that walled garden. And it always makes me cringe when I see some conference, some cloud vendor conference, you've probably been to one, and you see some CTO or CIO from company X come up and say, we're all in on Cloud X. And it's just like, oh, are you? Yeah, we're all in. We love the walled garden. It's great. That's a future. That can happen. Or we could start thinking in terms of virtual data centers. And what we get from that is we start thinking in terms of like clouds being the end all be all in the walled garden that it is. And we start thinking of like what it is. It's just a receptacle, a plug for the things that we actually need at commodity. And we start working with it at commodity pricing. And we build what we need to, what we want, wherever we need it. So just kind of summarize here the things that are going to give you success as you move forward with this. And if you want to do this, here's your steps or things to remember. And I think you probably picked this up along the way, but first and foremost, always design and optimize for portability. So thinking ahead and using something like Kubernetes, well, use Kubernetes first of all, because that is built to do what this does. And designing and optimizing around portability means that I would like to be able to deploy everything I need inside of this Kubernetes YAML file. And if there's something outside, let's say you're connecting to services, make sure that those are somewhat portable too. They use a common standard or something like that. Like for instance, Pulsar, that's a great standard that you can get in any cloud. And so if you want to connect to a service outside that uses Pulsar, great. But just remember that that's got to be portable. And then because of that, for portability, the flip side of that portability is don't do the unportable things, which is using cloud specific services, specifically data services, because data services are really sneaky ways to lock you in. And you will get locked in and you might even be happy for a while, but all of a sudden you'll notice that your bill is dominated by that particular service. And then finally, the open source contributing companies, look at who's contributing to open source. And this is just giving your support in that way, but just support those companies in some way. It doesn't even have to be monetary. Maybe it's just speaking at a conference or something like that. But it's like we want to keep the ecosystem of open source going. And at least, if anything, please contribute to open source projects that you use. And this is what makes it better and keeps the future moving forward. And then finally, and this is the big thing, the big part of this talk, and this is our plan, this is how we're going to take out the Death Star, is deploy the data centers, not servers. So think of everything as a virtual data center that you're going to deploy. And that, I think that is what we really want is when we think of things as we're deploying an entire data center, we think of all the things are portable. We're not thinking about locking ourselves into a certain cloud or a certain paradigm. We're creating portability, and it's not a huge trade-off. There are ways to make things just as awesome and probably better than what a cloud will offer you. You just need to look at it and look for it, or ask questions, or join. So what you could do right now, if you want to learn more about how to do this, you can go to ksandra.io. We have some getting started. We do these free workshops on YouTube all the time. Basic stuff like how to do Apache Cassandra stuff. We're doing Pulsar now as well. We have things on how to run Kubernetes, build containers. Our workshops are really fun and they're always really well attended. We're doing workshops right now that have thousands of people in them, and they're meant to be practical knowledge for people that are building things. They're for developers and they're for operators. So go check it out. YouTube is easy. And then finally, so this is what I want you to take away. And this is really important to me right now. This is really part of my mission is, Kubernetes lets us create virtual data centers for what we need. I think we've established that. We have some work to do to make it right and imperfect, but this is it. And that last frontier is data, which the clouds are trying to use to lock you in. We're going to take that back. So I hope you can join us doing that. We would love you in our community and helping us create a really cool future for the next generation of developers that are going to come along. Thank you very much. And I will leave it for any questions we have.
Thank you so much, Patrick, for that session. So I do not see any questions at this point. Please, if you have any questions, and if you also want to use the raise hand feature, that's also fine. So if you have any questions.
I'll stop my share, get out of here. Just my face.
Thank you so much for your session.
Yeah, no problem. I'm right at the time. I know that. So you have another session
Yeah,
to
exactly.
do.
Exactly, right at the time. Thank you so much, Patrick.
Thank you, Ruth, for being such a great host.
Oh, I see a question. So there's a question. You have to like hand you. Yeah. So
There's so Cassandra would be to Cassandra what Stimsy is to Kafka, right comparison. I don't know a lot about Stimsy, but I will I believe that is like a Kubernetes Kafka thing. There are a lot of projects out there that are doing this, like taking a existing project and then creating a project to build a Kubernetes version of it. I would hope that is, there are going to be more of those. Data on Kubernetes community is trying to pull those folks together. But yeah, I mean, I would just invite you, go check out cassandra.io. There's a lot of information on there about how it works. But yeah, it's meant to be, yes, like just here's your version of Cassandra running in Kubernetes.